till lecture number 9. In that we have seen, we have already started VBT, right? So VBT we have started, some of the concept we have seen. So what we will do, first of all, we will complete the limitation of VBT, and then we will start discussing like one by one, like coordination number 2, coordination number 4. Basically for you, it will be very much important for coordination number 4 and coordination number 6. So when I'm talking about coordination number 4 or coordination number 6, it means that you should be known that there are 4 monodentate ligand is attached and 6 monodentate ligand is attached respectively for coordination number 4 and 6, right? So first we will understand what are the limitation, and we will see the example. Okay, so these are only 2 or 3 points are there, limitation. Okay, so limitation like VBT does not explain the temperature dependent magnetic moment. Okay, it won't explain. Okay, it won't explain the temperature dependent magnetic moment. And for that, you should understand what is magnetic moment. Okay, how to calculate magnetic moment with the unpaired of electron. Okay, so when you will understand that, then you will come to know in the temperature dependent magnetic moment it is not expanding. So as you increase the temperature, the paired one will be it can be unpaired, or unpaired one can be paired up. Okay, so the temperature dependent magnetic moment, it is not explained, right? VBT doesn't explain color property of transition metal. Okay, we are not dealing here in VBT the color property. Okay, color property of different molecules or different coordination complex, we are not dealing over here, right? So color property also we are not discussing here, right? VBT doesn't explain the electronic transition of transition metal complex. So we are not dealing with the transitions, like how transitions is happening, right? So that we are not dealing. Understood? So the transition, whatever is happening here, electronic transition, simply like DD transition, we are not seeing over any type of transition. This is the limitation, right? Now, VBT doesn't explain the histochemistry of the complex. Here it is not explaining the histochemistry of the complex, only hybridization. It talks about hybridization, okay? Histochemistry, not discussing. DD transition, not discussing. Color property, not discussing. It won't explain temperature dependent magnetic moment. So these are the limitation, right? Now what we will do, one by one, we will see the coordination number. First, we will start with coordination number 4. Okay, coordination number 4, right? So with this coordination number 4, if you see, uh, generally we will have with this coordination number 4, either we should have sp3, or we will have sd3, or we will have dsp2, or sp2d, whatever you want. You can say about that sp3, sd3, sp2, dsp2, right? So sp3, we know that here it is tetrahedral, right? 1 second. Yes, here it will be tetrahedral. SD3, this is also no doubt it is tetrahedral. Excuse me. DSP2, it will be square planar. Okay, so SP3 or SD3, what does it mean? SP3 means 1s and 3p has participated, and it has four equivalent sp3 hybrid orbitals. So this is tetrahedral. Now SD3 means 1s and 3d is participated, and it is formed 4 SD3 hybrid orbitals. Now what about DSP2? 1d, 1s and 2p has participated, and it has formed DSP2, and it is square planar. Okay, so why it is square planar, why it is tetrahedral, we will so for sp3 we know that it is tetrahedral. We don't have any more point to say over here. We know that the participants groups, like participants orbitals, are 1s, and then px, then py, and then pz, right? Now sd3, in sd3 what we will have, we will have 1s, then we will have dxy, dyz, and dxz. I hope you know the orbital diagram. Okay, orbital diagram or orbital shape of the molecule, the diagram of the molecule. You are knowing this, right? So if you know that, then you will understand why we are choosing dx, dy, and dz. Can you confirm it whether you know this orbital diagram or not? What is the orbital diagram of dxy? What is dyz, dxz? If you don't know, then I will draw it out over here. That's why please kindly reply whether you are aware of the orbital picture of dxy, dyz, and dxz, and then dx2, y2, and dz2. Are you aware of that? Yes. Okay, very good. So what we will do now, if you are aware of that, fine. So then you come to know here for tetrahedral it is dxy, dyz, and dxz. It means these are in between axes. Okay, dxy is in between axis, dyz is also in between axis, and dxz is also in between axis. So that's why it is tetrahedral, right? Now all are using d orbital only. We will see the examples. Okay, it is not like without example we will not move. So we have examples for SD3 also. Excuse me. Okay. Now for square planar, what all orbitals are utilizing over here? It is like we have 1s, we have px, we have py, and then d we will have dx2 y2. See, dx2 y2 is in xy plane. That's why the d orbital we are using over here. This will lead the overall orbital picture towards the shape of the molecule towards the square planar, because dx2 y2 is directional, like in x direction and y direction, right? So that's why it is square planar. Okay, now going forward, coordination number 4, if you will start one by one with example, with that example only we will come to know what are strong field ligand and what are weak field ligand. Okay, so in this coordination number 4, first we will start with tetrahedral complexes. Okay, VBD of tetrahedral complexes, right? Like we have nickel Cl4 2 minus. So this is a type of Ma4, right? So what is the oxidation number in nickel? Okay, can you fast calculate and tell me the oxidation state of nickel? What I'll write over here, oxidation state of nickel. Can you calculate and tell me fast? What is the oxidation number? You should be with pen and paper. +2. Very good. So +2, it means we know that nickel in at +2 oxidation state, as I told you in d orbital, you should be aware of uh, the outermost electronic configuration with respect to +2 oxidation state, because that is only going to help you out. Okay, so it will make your journey very easy. So nickel at +2 oxidation state, it means if you draw 3D 1 2 3 4 5, so 3D 8 and then 4s 0, because nickel at +2 oxidation state we will have only 3d8, right? So 1 2 3 4 5 6 7 8. Now as I told you in previous classes that chloride, okay, chloride ion is weak field ligand. Okay, I'm just mentioning with the red color, this is weak field ligand, WFL. Okay, weak field ligand means it is not having that much power to pairing up the electron. Okay, so d orbital's electron, it won't be pairing up. So if it is not pairing up, then we are left with 4s, we are left with 4p, and we are left with 4d. Okay, but see how many orbital do you need? As I told you in classes also that the demand and supply, if 4 chloride is coming, then you have to occupy 4 orbital. If 6 are coming, you have to occupy 6. Now 4 are coming, 4 chloride is there. So let us take the 4 chlorides negative charge and fill it up with the orbital. So 1 chlorides 2 electron, it is donating 2 electron. Second chloride, third chloride, and fourth chloride. Done. Chloride, 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 and chloride. Now you just see how many orbital has utilized 1s and 3p. So that's why it is sp3. right? And sp3 means we know it is tetrahedral. So likewise you have to calculate. Okay, now you have to draw the geometry over here, right? Excuse me, you have to draw the geometry. So you have nickel over here. This is the tetrahedral. Okay, you can direct dot it, you can draw it because lone pair will not affect over here. So chloride, 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 and chloride. Understood? So like this, you have to draw. Got it? So here, what else we can get it? See, this practice should be there with you. Now they will ask you in this sp3 what all orbitals has been taken like participated. So it is 4s, then 4px, then 4py, and then 4pz. This practice you keep it, okay? There are so many questions where directly they will ask which orbital has been like in case of coordination complex only they are going to ask you which orbital is taking participate in this hybridization, right? So like that questions they may ask you. So always remember this. And then along with that, with this hybridization is sp3. Geometry you got tetrahedral. Now they will ask you number of unpaired electrons. Okay, number of unpaired electrons. This is very much important. Okay, with this number of unpaired electrons, I am going to give you one trick for the Bohr magneton value, the magnetic moment. Okay, spin only magnetic moment. I'm going to tell you, and that is also very much easier way. I'll tell you. So here, number of unpaired electron n equal to, you just count it, how many are there? You see 1 and 2. These two are only unpaired, right? So here number of unpaired electron is 2. So if you are doing pairing up, if you are not able to find whether it is a weak field ligand or a strong field ligand, what will happen? You will do pairing up over here. If you are doing pairing up, then 0 electron will be there. Number of unpaired electron will be 0. And if unpaired electron is not present, then that will be diamagnetic. Okay, so everything is going to be wrong. So now number of unpaired electron you have 2. So this will be paramagnetic. It means your this nickel Cl4 2 minus is a paramagnetic complex, right? Like that questions it will ask. I'll give you the questions, the real questions, what they are asking in CSIR net or IIT JAM and GATE. That questions I'll give you. You just see this type of questions generally they are asking. Number of unpaired electrons, whether it is a paramagnetic or diamagnetic. Now, finally, what is the spin only magnetic moment value? So they will ask you spin only magnetic moment, right? The symbol is mu spin. Mu is magnetic moment. Now mu spin means spin only magnetic moment or mu effective, either mu spin or mu effective. This or mu effective, like that they will ask you. So what is the formula of mu effective or mu spin is under root n plus 2. Okay, this much Bohr magneton. Bm is nothing but Bohr magneton. Okay, Bohr magneton. This is the unit of this magnetic moment, right? Bohr magneton. Now n, what is n over here? N is number of unpaired electron. See, if it is an academic level question, then you just put 2 over here and then solve. And if it is a competitive level, I'll give you one trick over here, and that is going to work. 1 point or 2 point here and there, it will be there, but approximately you will get. If your n value is 1, the value will be 1.73 Bohr magneton. You can put this value in this formula. Okay, you can put this value in this formula. You will get this much Bohr magneton only. Okay, this is already calculated. If it is n equal to 2, see, this will make your life very easy. 2.87 Bohr magneton. If it is n equal to 3, the value will be 3.87 Bohr magneton. If n value is 4, then it is 4 point, 1 second, it will be 4.92 Bohr magneton. If n value is 5, then it will be 5.92 Bohr magneton. What about if n equal to 6? Can you reply? What about n equal to 6? Approximately, can you tell what will be the answer if n equal to 6? Approximately, not exactly, but approximately 6.9. Okay, we'll see. See, this is your orbital, d orbital, 1, 2, 3, 4, 5. Now, if one unpaired electron, 1.73. If two unpaired electrons, 2.87. If three unpaired electron, 3.87. If four unpaired electron, 4.92. If five unpaired electron, 5.92. Now, for six, there is no position. If sixth one you are writing, then left with four unpaired electron. So, there is no n equal to 6 we are calculating over here. Understood? So, here only this much will be there, not more. This you should be understand. So, that's why only these five values are there. Keep on practicing, you will get to know. See, it is very simple. If it is 1, if n equal to 1, then it is 1.73, right? If it is 2, then it is 2.77. If it is 3, then it is 3.87. 4 means 4.92. 5 means 5.92. Only these five values are there, nothing else. Now, again, if you say that sixth electron, where it will go? So, sixth electron here it will come, seventh electron here, it means three unpaired electron. Eighth electron here it will come, it means two unpaired electron. Ninth electron will come over here, one unpaired electron. Tenth electron will come over here and equal to 0, right? So, 0 Bohr magneton. So, this value should be with you, right? This is very important. So, now here n value is 2 unpaired electron, right? So, here the value for mu effective will be 2.87 Bohr magneton. Sometimes they will ask this value. Okay, sometimes they will ask this value. So what you have to do now going forward, whether it is coordination number 4 or coordination number 6, whenever I'll ask for coordination number 4 or 6, if I give any example, what all you have to calculate with that example, you have to calculate oxidation number. Okay, with that example, you have to calculate oxidation number. You have to find hybridization. Okay, I'll just list out over here with any example. If I'm giving you example, with this example, what all you have to calculate, you have to calculate first oxidation state, then you have to calculate hybridization, then you have to calculate the orbital, participating orbitals. You have to find participating orbitals. So if you are keep on for each questions, if you are doing all this exercise, it means everything is getting revised in one place, right? So participating orbitals, after participating orbitals, you need to find geometry. After geometry, you need to find whether it is a like number of unpaired electrons, n value. Then you need to find whether it's a paramagnetic or diamagnetic. Then you need to find what is the Bohr magneton value or mu effective. What is the mu effective value? So this all you have to find it out with any example if I am asking you going forward. So you have to find oxidation state, hybridization, participating orbitals, geometry, n value, para or di, mu effective. If you are calculating all these things for each and every examples, see, then no need to memorize anything. Everything will be perfect in your mind. It will be sit in your mind, okay? And you can utilize. Now, the next example I am giving you, nickel carbonyl 4 times. Now you just see nickel carbonyl 4 times you have. Now carbonyl is a strong field ligand. Now for time being, I'll tell you every time like what is this ligand, strong field ligand. But when the ligand is repeating, that time I won't say. So that you should be keeping in your mind whether it's a weak field ligand or a strong field ligand. Okay. So now carbonyl is a strong field ligand. Now can you do this exercise and find it out? What is the hybridization in this case? First of all, just tell me what is the oxidation number for nickel over here? Oxidation state. Nickel. What will be the oxidation state in this nickel? Zero. Very good. Right? Zero means we have total 2, 8 plus 2, 10 electron we have, right? No need to write 3D 8 and 4s2. See, it is not required. We are not asking you for to write electronic configuration. Anyway, this is a strong field ligand. It will pair up. So total you have 10 electron, right? Total you have 10 electron. This much only you should know. Whether D, how much in D, how much in S, no need to worry about that. When you have a strong field ligand. So strong field ligand means it will pair up. So now you just draw the D orbital. 1, 2, 3, 4, 5. So 3D, this is 4S, this is 4P. Now 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electron field. Because whatever was present in 4S, it came over here. Like initially it was like this. 3D8 and 4s2. Now, what it will do, here unpaired electrons are there. Here it is a strong field ligand. So it will do the pairing up. These two electrons will come and sit over here, right? Now, how many carbonyl are there? 4. So 4 carbonyl will come and it will donate its lone pair. 1 carbonyl, second, third, and fourth. So carbonyl, 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 and carbonyl. 4 carbonyl. It means 1s3p. So sp3. It means this is tetrahedral. Okay, so oxidation number is 0, right? Oxidation number done. Hybridization sp3 done. Now participating orbitals. Very simple. 4s, 4px, 4py, 4pz. Right? This practice, see whether you know or don't know, but still, if you are knowing also, you have to write down this. Okay. So if you are practicing with this, it is fine. Now participating orbital done. Now geometry. Geometry, we know that tetrahedral already we have written. So geometry done. Now number of unpaired electrons. You just see number of unpaired electrons is equal to 0 over here because all are paired, right? See, we are not seeing this electron for number of unpaired electron. Okay, we will see only the parent's electron, whatever is present before, right? So n equal to 0. N equal to 0 means it's a diamagnetic. Okay, then what about mu effective value is 0 Bohr magneton because we don't have any right unpaired electrons. So if we don't have, then everything gone. See, we have covered everything or no? N paradi mu effective. So we have covered everything. See, this much little space we will conclude all the things. So don't worry about that, right? So it means we have. Okay, I give you some of the examples. You just do your homework and then let me know. And one more thing, I just wanted to add over here. As I told you, if you have, see, nickel, and then you have another example we have taken, this also nickel. Okay, nickel or whatever 3D elements, all the 3D element, it will work with a strong field ligand as well as with weak field ligand. Okay, two separate things it will work. But if you have 4D element and 5D element, everywhere pairing up will take place. Pairing of the electron. But here strong field ligand pairing up, weak field ligand no pairing. This you remember only for 3D. But 4D and 5D, whatever will be there. Like suppose here we have nickel chloride, right? Nickel Cl4. If we have platinum Cl4, then it will be square planar. Understood? If it is platinum Cl4 and 2 minus, it will be square planar because platinum is 5D element. If it is 5D element, then it is come under pairing up, right? It will pairing up because it's a bulky metal. So it is very strongly laid and it will allow to pairing up, right? It will be acting as a strong, very strong. So it will allow to pairing up. Understood? So few homework I'm just giving. You just practice with yourself and let me know the answer. Okay. Here only I'm drawing. So these are the homework. So at least you should do this homework. So first one I am giving you cobalt NCS 4 times 2 minus, and then B I am giving you manganese Br4. This I will not give because see, if I give, then okay, I'll giving you, then I'll explain you. Okay, and then C cobalt Cl4 2 minus. Only these three. You do it and you send it to me. Okay. So thank you.